Uh, to do the timer programming. Okay, previously we already did this what we call it examples here, which is we are based on the given, all right, given these programs here. Okay, you are required to find out what is the delays that are created according to this coding here. Okay, so moving on to the next slide. Okay, so this is how you're going to find out the value to be loaded in the timer, which is what is your T, C, and T values. Okay, we already know that. Okay, I already give to you earlier, which is in the last class. Okay, there are three what we call here three equation that you need to remember. Okay, the first one here is period, okay, equal to 1 over f, okay, which is this f here is, okay, f new equal to f divided by your prescale. Okay, if no prescale means that the prescale value is 1, so f divided with 1, you will get the same f lah. Okay, if you're using the prescale, then you need to divide this f here with a new value so that you will get the new f clocks, and then after that you will find the period for this f here. Okay, so this is the first equation. Okay, the second equation that you need to remember is the delay, okay, which is delay equal to T multiplied by count. Okay, so this is the second equation that you need to remember. Okay, usually what we're going to find out is the value of count. Okay, so selalunya delay is given. T also you can find out from the Excel. Okay, then what you're going to do is you need to find out what is the count. Okay, once you get the count, and then now we go to the third step, or the third equation here is T, C, and T equal to, okay, FF, okay, which is the maximum for 8 bits counter register, minus with count, okay, the value that you already get from the second, what we call it, second equation, and plus with 1. So then after that, you will get the T, C, and T value. So this T, C, and T value, okay, after you get the values, you put it to your programs. Okay, and let's look at these examples here. Okay, so assuming that you have the Excel of 8 megahertz, okay, given that the Excel sama dengan 8 megahertz, and then you're going to write a program to generate a square wave with a period of 12.5 microsecond. Okay, so what you're going to do is, okay, we lukis dulu, okay, our Atmega 32, and we have the PB3 here. Okay, this PB3 is used to generate a square wave. Okay, so this is the square wave, and is telling, okay, it tells us that, okay, the square wave period is 12.5 microseconds. So you know that this square wave, okay, the T is equal to 12.5 microseconds. Okay, from this square wave, okay, or this period from the square wave, okay, you can find the delay actually, okay, which is, as we know that, okay, the delay is actually this duration of time. Okay, so this is the delay to generate a logic high and logic low. Okay, so we assume that when you generate a square wave, okay, the duty cycle is always 50%. Okay, which is the duty cycle for logic 1 is equal to the duty cycle of logic 0. So from this T here, okay, you can find out the delay. Alright, di mana delay sama dengan T period of your wave, okay, you divided by 2. Okay, so half cycle, you will get 12.5 divided by 2, and you will get 6.25 microseconds. Okay, so this is the half cycle. which is half cycle is actually the delay that you're going to generate. Okay, every time you're going to produce logic high and logic low. Okay, so this is the information that you get from what we call here, from this question here. Okay, and from here, okay, what you're going to do is, okay, kita dah dapat dah kita punya delay. Okay, now we're going to find out what is the TCNT. Okay, because after you get the TCNT value, then after that, barulah you can do this program. Okay, you can proceed with this program here. Okay, go first. Okay, by using the first equation, T equal to 1 over F. Okay, since in this question here doesn't, okay, it not stated what is the prescale. Okay, so we assume that the prescale is 1. Okay, which is no prescale is used. Right? So, no prescale, timer 0, and this one here going to use a normal mode. Okay, because we are in the normal mode programming. Okay, so we use the normal mode. Okay, so first find the T. Okay, what will be the T? T is 1 over F. Your F is 8 megahertz. So you will get sama dengan 0.125 microseconds. Okay, so this is the first equation. Okay, and the second equation, okay, which is delay, sama dengan T multiplied by count. Okay, delay, you already get the delay, okay, which is the half cycles of the square wave. Okay, so you put 6.25 microsecond. T, oh sorry, not delay. Okay, betul. Delay is 6.25 microsecond, while T is 0.125 microsecond, and multiply with count, and then next you will get what is the count value. Okay, 6.25 microsecond divided with 0.125 microsecond, and you will get berapa kat sini? 50 times. Okay, 50 kali. Okay, so this is the count. Okay, once you get the count, then the third step here is, okay, by using the TCNT equal to FF, or you can use a 255 minus count plus 1. Okay, so I just use the 255 minus 50 tambah 1, and you will get berapa kat sini you get? What would be the value here? Do you have a calculator? Okay, 255 minus 50 and plus 1, you get 206. And this 206, if you're going to, what we call here, change to hexadecimal, it equivalent to 0x. Berapa? Base 206. Hexadecimal. Okay, you will get CE. So this is your TCNT value. Okay, once you get the TCNT value, then after that, we can do the programs. Okay, so first, okay, so now, okay, you know that you have a port B pin number 3. This port B here used to produce a square wave. Okay, so by right, you know that this port B pin number 3, you're going to make it as a output port. Okay, so now what you're going to do here is started with your hashtag include, and then avr/io.h, and after that, okay, we start with the name of the delay lah. We initialize the delay, okay, the function of the delay or subroutine of the delay that we're going to create. Okay, so contoh lah, void delay 6 to 5, okay, for example, 6 to 5 microseconds, okay, and then void. Okay, and started with your main program. Okay, so this is the things lah that you need to put inside of your main program. Void. Okay, mula-mula, what you're going to do is here is, okay, we need to initialize the input output port of ArcMega 32. Okay, since this one here on the port B, okay, which is PB3, you're going to make it as output port. Okay, you can simply write DDRB equal to OXFF. Means that you make the whole port B as a output port. Ataupun, if you don't want to make the whole port B as an output port, only PB3 as output port, you can simply change to, okay, atau DDRB, okay, we do use the data shifting, okay, shift 1 to the left by 3 bits, okay, so means that PB3, you make it as a output port, while the rest of the bit will you make it as a input port. Okay, and then we initialize port B equal to 0. Why you put port B equal to 0 means that you're going to start it, okay, start this one here, or sometimes you can do something like this. Okay, if you don't want to do this pun can, kalau tak nak buat yang ni. Okay, so I just, okay, so after you initialize your input output port, so next, okay, we start with a while loop lah. Okay, so Y1, open curly bracket and close curly bracket. Okay, mula-mula, what you're going to do is you need to, okay, produce the logic low of this square wave. Okay, how to produce that? Okay, you simply give port B equal to 0. So means that the whole port B you give is 0, which is PB3 also get the 0. And once you give this value, then what you going to do? Okay, we're going to call the delay. How many seconds that you're going to generate this low level? Okay, the logic 0. Okay, so we call a delay. So this is the delay name. Delay 6 to 5. Okay, and then this is to produce a logic kosong lah. Okay, then after that, you're going to panggil pula untuk produce a logic high. Okay, so you simply write port B equal to 0x. Okay, so this one you can use the 0x or 0b pun can. Okay, which is in the binary. Okay, it's just use the binary numbers here. 0b. Okay, 0, 0, 0, 0. And bit number 3, I put 1. The rest I put 0. So now what happened here? My square wave started with a logic 0. Now it becomes logic 1. So how many seconds I'm going to produce this logic 1? Okay, which is 6.25 microseconds. So I call the same delay. Okay, and this process will keep repeating until you stop the program. So it will produce a square wave at your port B. Okay. Any question up until here? Okay, this is only for the main program lah. Belum lagi kita masuk the delay punya programming. Any question up until here? Okay, no question. Okay, for the delay programming, okay, so what you're going to do here is, okay, so we void, okay, and then delay 6 to 5. Okay, you put back the name of the delay that you already initialized sebelum ni. Alright, and then buat dia punya coding. Okay, so this is the coding lah inside here. Okay, we already learned that there are a few steps that you need to remember. Okay, the first step, what will be the first step? You need to initialize your TC and T. Okay, that your first step. Okay, previously, okay, so this is load your TC and T0. The second step, set your TTCR. then monitor your TOV0, stop timer, clear TOV0, and go to step 1. So this is the step that you need to do, okay, for the timer programming by using the normal mode. Okay, so now we start with load TCNT value. So TCNT 0 lah. Why 0? Because we are using the timer 0. Okay, so that's why we use the TCNT 0. So what the value, okay, is to you're going to put to TCNT 0. Okay, we already calculate the value. So this is the value. Okay, you can use the decimal value or the hexadecimal value. Okay, if you're going to make use a decimal value, so simply write 206. So this 206, you put it your TCNT 0. Okay, and this would become your first step lah. Okay, the second step, apa nak kena buat? Okay, then second step. The second step, you need to set your TCCR 0. Okay, so TCCR 0. Recall back, this is your TCCR. Okay, so TCCR0, since we are using a normal mode, okay, so bit 6 and bit 3, mana bit 3? Okay, so this one, okay, what would be the value that you're going to put here for the normal mode? 00 or 01? Who's going to help me? What is the value that you're going to put here at bit 6 and bit 3 for the normal mode or overflow mode? The other name is overflow mode. Okay, so the value is 0, 0. Okay, so you put 0 here and 0 here. Okay, that is the for the mode setting lah. Okay, then this last three bit. Okay, bit kosong, bit 1 and bit 2. So this is your prescale. Okay, so what the value that you're going to put to your prescale? Okay, since this one here, no prescale is used. Okay, for the no prescale is used, the value that you're going to put in this bit here is 0, 0, 1. Okay, so the rest you fill up lah with 0. Okay, so this is equivalent to 0, 1. Okay, so you can simply write 0x0, 1. So you know that this is a normal mode with no prescale. Okay, so that is a step number 2. Okay, next step number 3. What would be the step number 3? Okay, step number 3, you need to monitor the TOV flags. Okay, how to monitor the TOV flag? Okay, by using the while loops, okay, which is Y, and then TIFR, okay, and with, okay, your TOV flags. Okay, so you need to look lah. Okay, you need to refer to your TIFR. Okay, what bits the TOV flag is located. Okay, so in this case here, okay, we go back to the TIFR. Mana kita punya TIFR? So this is TCCR0. Okay, so this is the TIFR, right? For the TOV0, which is a normal mode for timer 0, okay, the bit is at bit 0. So the value that you're going to check is, okay, 0B0000001. Okay, you're going to check this flag here. Either it is already set 1 or not. Okay, so this is equivalent to 0x01 lah. Ataupun, okay, you can simply type, okay, TOV0. Means that, okay, shift 1 to a location kat mana? TOV0. Okay, so this is all similar lah. Okay, equal lah, which is equal to this value here. Okay, so I just use this one here. Okay, 1 TOV0, and then after that, Okay, check whether it's equal to zero. If it is equal to zero, okay, so next sekejap. Sama dengan kosong. Okay, you check either this bit is it sama dengan kosong. If yes, it will keep repeating. If not, so what happen here? Step number 4. Okay, you need to stop the timer. How to stop a timer? Okay, by put 0 to this prescale here. Okay, if you put 0, 0, 0, okay, this combination of input here, so what happen? The timer will be stopped. Okay, so TCCR0 sama dengan kosong. So this is to stop the timer. And step number 5, okay, you need to reset your TOV flag. So how to reset the TOV flag? Okay, you need to put 1 to your TOV 0. Okay, you can simply write TIFR sama dengan OX01 ataupun sama dengan 1, put 1 to your TOV 0. Okay, either way. Okay, so this one, if you use this value here, so you need to know lah the location of your TOV0. Kalau kamu buat this bit shifting, okay, no need to know the location of the TOV0, but you need to know the name of the bits. Either is a TOV0, TOV1, TOV2, or CR1, etc. Okay, so this is the delay programming to generate a delay of 6.25 microseconds. Any question up until here? Ada soalan?
No question at all.
Okay. So if no question, okay, next we go to the next slide, okay, which is how to generate a larger delay. All right. So previously, okay, the size of the time delays depend on 2 factors. Okay, which first, either your crystal frequency, which is your X-tel. Okay, we know that T tak nampak pula. Okay, T sama dengan 1/f and delay equal to T multiplied with count. Okay, so what happen here is if your F is bigger, what happen to your T? Your T will be smaller. Okay, when your T is smaller, what happen to your delay? Dekat sini, delay will be small as well. Okay, when your F is smaller, so what happen to your T? T akan become bigger. And when your T is big, the delay as well, you can generate a large delay. So first is depending on the crystal frequency. Okay, your X-tel value. Okay, the second one here is the timer counter register. Okay, which is your TCNT. Okay, your TCNT. Is it 8-bit ataupun 16-bit? Okay, if 8 bits, what happen if 8 bit? Okay, because we know that TCNT sama dengan FF minus count plus 1. Okay, so what happen if your TCNT is 8 bits? So the maximum here kat sini is 255 only. Okay, and if you have a 60 bit, so the maximum value here is 65,535. Okay, so the value is depend on the what we call here 2 factors. Okay, either it is from your crystal frequency or from your TCNT size. Okay. Kejap ya. Okay, so in which the largest time delay only achieved by making the TCNT 0 sama dengan 0. Okay, kenapa kita kata to generate a largest time delay, okay, we need to make sure that the value of TCNT sama dengan kosong. Why is that? Okay, okay, if you recall back, the principle of the overflow, okay, the delay generated for overflow is depending on the here, okay, not depending of the how many water that you can fill inside of this bottle. Okay, if you put your TCNT somewhere around here, so this is your delay that you can generate. If you put a TCNT here, TCNT which is equal to 0, okay, which is you empty your water bottle, what happens? The delay will become the maximum delay, the largest delay that you can create before, okay, the water overflow from this bottle after we put the water inside here. Okay, so to create a largest delay, how to achieve it? By put the TCNT sama dengan kosong. Okay, what if that is not enough? Okay, the answer would be use a prescaler option. Kenapa guna prescaler option? Because by using a prescaler, okay, we recall back, okay, the F new equal to F divided by prescale. Okay, so what happens if you use a prescale? Okay, the F will become smaller. Okay, the largest prescale, the larger the prescale that you're going to use, the F value will become small. And what happens if your F is small? The T will increase. Okay, when the T is large enough, and then the delay will become bigger. Okay, so that's why we use the prescaler option in TCCR to increase the delay by reducing the period. Okay, so the prescaler option allows us to divide the instruction clock by a factor of from 8 to 10 to 4. Okay, so this is the prescale available. Okay, for timer 0, sorry. Okay, you can choose prescale with 8, 64, 256, and 1024. Okay, and then this is the combination lah. Okay, no prescale or stop the timer, the combination would be 000. What about this one here? No prescale is 001. Clock 8, 010, and this is 100 until number 7 is 111. Okay, so this is how the prescale works. Okay, so previously with no prescale enabled, the crystal oscillator frequency is directly fed into timer 0. Okay, without a prescale, okay, which is here, you see this is the clock. Without a prescale, what happened here? Whatever value from this clock will go to this, okay, clock source. Okay, so if the prescale bit is enabled, okay, we need to divide the clock before it is fed into the timer 0. So this is the clock that you need to divide by the prescale. Okay, the lower 3 bits of TCCR0 will give the option of the number we can divide. Okay, by 8, 64, 256, and 1024. Okay, let's look at this example here. Okay, find the timer, clock frequency, and 8 period for the various AVR-based system with the following crystal frequency. Assume that the prescale of 64 is used. Okay, you have the external 8 megahertz. Okay, so what you're going to do here is first divided this 8 megahertz with 64, and you will get 1 to 5 kilohertz. And then after that, okay, from here you find the new T is 1 over 1 to 5 kilohertz, you will get 8 microseconds. Okay, if your external is 60 megahertz, okay, so what you're going to do is divide it with 64, and you will get 250 kilohertz. And from there, you find out the T, so the T will be 4 microsecond. Okay, similar to the C here, 10 megahertz. Okay, 10 megahertz divided with the prescale 64, you will get 156.2 kilohertz. From here, okay, you obtain the T by using the formula T equal to 1 over F, and you will get 6.4 microsecond. Okay, this is another example. Okay, find the value of the TCCR0 if you want to program timer 0 normal mode with a prescale of 64 using an internal clock for the clock source. Okay, so you're going to find out what is the TCCR0 value. Okay, given that, okay, normal mode and prescale sama dengan 64. Okay, so what you're going to do here is, okay, you draw your TCCR. Okay, so this is your TCCR0. All right, locate the bit 6 and bit 3. Okay, so this is a bit 6 and bit 3. And then, given that it is a normal mode, so you know that for the normal mode, you need to put 0 for this bit here. And then, next, we look at this one using the 64 prescale. Okay, so you need to find out what is the prescale. Okay, the combination of the input inside here. Okay, on the prescale punya region. Okay, so 0, 0, 0. Okay, you know that this is a stop timer. 0, 0, 1. What will be a 0, 0, 1? No prescale. 0, 1, 0. Okay, so this is what we call here with a prescale 8. Okay, and then 0, 1, 1. Okay, so this is a 64. Is it 64? 0, 1, 1?
Yes, 64.
Okay, 64. And then you have a 256 after that. And 1024. Okay, 256 is 100 and 1024 is 101. Okay, so now you're going to use the 64. Okay, so this is the value that you need to put inside of this, sorry, this region here. Okay, 0, 1, 1. Okay, so then after that, okay, you write down TCCR0 equal to, okay, the rest you put 0 lah. Okay, divided this one to 4-bit region. So this is a 0 and this is 1, 2, 4, 8, 0, 3. Okay, so this is the value that you're going to put to your TCCR0 for normal mode with a prescale of 64. Okay, another example. Okay, we have a lot of examples here. Okay, assume that the X is 8 megahertz. Okay, find the clock period. Okay, fed into the timer 0 if a prescale option of 104 is chosen. B, show what is the largest time delay we can get using this prescaler option and timer 0. Okay, given that X sama dengan 8 MHz, timer 0, and prescale 1024. Okay, so what are you going to do? Okay, so first, because now you have a prescale, you need to find the new F lah. Okay, sama dengan 8 MHz divided with 1024. Okay, you will get, okay, sama dengan 7.8125 kilohertz. Okay, so this is your F new. Okay, then you find your T clock. Okay, your period of your clock sama dengan 1 over F. Okay, so this is your new F, and then you will get the value of your T is 0.128 microsecond. Not microsecond, sorry, milliseconds. Or equivalent to 128 microseconds. Okay, this is a A lah. Okay, find the clock period. Okay, and then B, show what is the largest time delay we can get using this prescaler. Okay, how to obtain the largest time delay? Okay, if you're using a normal mode, by set your TC and T sama dengan kosong. Okay, so by using the formula TC and T equal to 255, or sometimes you can use the FF lah, FF or 255. Okay, I just use the FF lah. Okay, to be consistent. Minus count plus 1. Okay, T set and T, I put 0 to generate a largest time delay. So I will get the count sama dengan FF is 255 plus with 1. So this one here is 256. Okay, the maximum count is 256. Okay, from here, we put to equation number 2, which is delay sama dengan T multiply with count. Okay, your T is 1 to 8 microseconds. 256. Okay, the largest time delay that you can generate here is 32.768 milliseconds. Okay, so this is the largest time delay that you can generate by using the timer 0 with an external frequency of 8 megahertz and the prescale is 1024. Okay, for example, if you're going to generate a delay of 200, not 250 millisecond, can you do it by using a timer 0? Cannot. Okay, you cannot generate a 50 millisecond by using a timer 0 because the maximum that you can generate is up to 32.76 millisecond only. Unless, okay, you find out, okay, a delay for 25 milliseconds, okay, do the programming for delay to 25 milliseconds, and then you call it twice, okay, that delay. Then you can generate a 50 millisecond by using timer 0. Okay, if you're going to program, okay, 50 millisecond directly using a timer 0, you cannot do that because the maximum is 32.76 millisecond. Okay, if you break it to a few or you can, if you're going to call it a few times, okay, then you can use the timer 0. Okay, so in this case we call it 2 times, okay, to generate a 50 millisecond by generating a 25 millisecond delay subroutine. Okay, so let's look at another examples. Okay, assuming that external is 8 megahertz, okay, write a program to generate a square wave of 1 to 5 hertz frequency on a pin port B using timer 0 normal mode with a prescale 256. Okay, so how to do it? Okay, first we draw the Atmega 32 and this is your PB3. Okay, this PB3, okay, to generate a square wave, and given that the frequency of this square wave, okay, dia bagi tahu kat situ frequency of the square wave is 1 to 5 hertz. Okay, using timer 0, okay, and then it's given that external equal to 8 megahertz, timer 0, normal mode, and prescale sama dengan 256. Okay, so what you going to do? Okay, you need to find out lah what is the delay duration that you're going to create. Okay, how to do that? Macam mana nak dapat? Can you tell me how to do that? Okay, you already have this f of the square wave. From this f square wave, apa yang kamu boleh dapat? What you can obtain from this frequency of the square wave? You can get the period for the square wave, okay, which is 1 over 1 to 5 hertz, okay, and you get what would be berapa dapat kat sini? 8 milliseconds, okay, 1 over 1 to 5 hertz, you will get 8 milliseconds. So this is the period for the square wave, and from this period here, you can get the half cycle. Okay, so this is one cycle lah. Okay, one cycle, the T here, this is the T of square wave. sama dengan 8 millisecond. Okay, half cycle equal to 4 millisecond, which is half cycle is actually the delay that you're going to generate. Okay, because okay, so this is the delay lah. The half cycles, this is a delay, and this is a delay to produce a logic 1. Okay, produce logic 0, call another delay to produce a logic 1. Okay, so from here, what are you going to do? Siapa nak tolong? After you get the, what we call here, after you get this delay here, okay, then what you're going to do is you need to find out the TCNT lah. Okay, what will be the TCNT value? Okay, so first, okay, get the F. Okay, F new sama dengan your Esther divided with Prescale 8 megahertz divided with 256. Okay, you will get 31.25 kilohertz. Okay, from here, okay, find the new T, okay, which is 1 over F new. Okay, and then you will get berapa kat sini? 0.032 milliseconds or 32 microseconds. Okay, and then after that, by using the second formula, delay sama dengan T multiply with count, then we will get count equal to delay. What would be your delay? Delay tadi kita nak generate 4 milliseconds. Okay, divided with 0.032 milliseconds, and you will get 125 times. Okay, so from here, obtain your TCNT sama dengan FF minus count 125 plus 1, and you will get, okay, 83. So this is the value that you're going to put to your what we call here TCNT 0. All right, and then after that, after you get the TCNT, after you obtain the TCNT, and you write down your program lah. Okay, so I only focusing on this part je lah, yeah. Okay, because this one you already know how to initialize your input output port and how to make a toggle mode, okay, to produce a logic 0 and logic 1. Okay, I'm only focusing on this part here, okay, to generate a delay. Okay, so we started with void delay 4 milliseconds, for example. So this is the name of the delay subroutine. Okay, TCNT0 because timer 0. So what will be the value for the timer 0? Timer 0, the value that you're going to put here is 83 after we did the calculation here. All right, and the TCCR0. Okay, what will be the TCCR0? Okay, again, go back to your TCCR. Okay, find out what will be the value that you're going to put. Okay, kat sini and here. Okay, you're going to put 0 lah because this is a normal mode. And this is a 256. So 256, what would be the value for the 256? Kita dah dapatkan tadi. 256 is 100. Okay, so this is the value that you're going to put on the prescale punya bits. Okay, so 100 and the rest you put 0 and change this one here to apa tu hexadecimal representation, so you will get 0, 4. Okay, so this is a 0, 4. Okay, or you can put the 0x04 pun okay. Or you can put this symbol of this dollar sign symbol pun sama juga. Alright. And this is the second step lah. Okay, and the third step, okay, why TIFR, okay, you're going to check lah your TIFR for the TOV. Okay, I just put this one here. TOV0. Is it sama dengan 0? If yes, it will keep repeating here. If your TOV0 equal to 1, which is the overflow has occurred, so what happened here? You stop the timer. And then reset your TOV0 flag by putting 1 to your TOV0. Okay, you can use this representation TOV0. Okay, if you look at this, okay, we have already did a few examples. Okay, if you look at the timer punya programming, okay, the things that you're going to change here is only this value. Okay, the TCNT0 value, the TCCR0 settings. Either you're going to use a normal mode ataupun CTC mode and the prescale value. Okay, and then this flex. Okay, so this is where you're going to change the value lah. Alright, yang ni sama. Step number 4, always same. And this flex. Okay, only these 4 locations that you need to change according to the question. The rest, just follow, okay, the step given in the earlier class. Okay, kat sini je kamu kena tukar. Yang lain semua sama. Alright, so that is for the normal mode. Any question up until here? Any question from you? Tak ada soalan eh? Okay, baguslah. Kelas ni tak ada soalan. Alright, so next we go to the next slide. Okay, so this is how to do a timer programming by using this CTC mode or compare mesh. Okay, for the CTC mode, okay, another register, as I said in the previous class, needed, that's called a OCR0 register. Di mana, okay, in which this register here is used to compare with your TCNT value. Okay, if OCR value equal to your TCNT value, what happen here is the OCF flag akan raise ataupun akan flat. Okay, so as in the normal mode, in the CTC, the timer is incremented with a clock. So every time you give a clock impulse, okay, the timer will keep increasing. Okay, so it count up until the content of TCNT equal to OCR0. Previously, okay, we need what happened when overflow, okay, when the value roll over from FF to 0. So what happened here is the TOV0 will be set. But now for the CTC, what happened in the CTC mode is you need to compare the TCNT0 TCNT0, is it equal to the level, okay, the water level that you set earlier? Is it sama dengan OCR0? If yes, what happened? OCF0 will be set. Okay, so this OCF0 flag is located in the TIFR register. Okay, so this is your TIFR register. Okay, so you have 8 bits. Okay, this bit here is for the TOV0 and your OCF0 is inside here at this bit. Okay, bit 1 inside of your TIFR. Okay, so I think we stop here. Okay, this is the introduction for the CTC. Okay, next class, okay, we're looking at how to write the compare mesh mode. Okay, for the compare mesh mode, okay, the step here that you need to remember here is, okay, for the CTC mode, okay, there are a few steps that you need to do. Okay, first step, okay, clear TCNT. Okay, your TCNT must always you set it as a 0. Okay, you need to clear your TCNT. So this is the step lah for the CTC mode programming. Second step, load OCR value. Okay, so how to load OCR value? Okay, you need to calculate lah. Okay, and previously, okay, you have three formula. Okay, three equation. The first equation is to find out what is your T. The second equation is to find out the delay, and the third equation, okay, for the CTC mode is, okay, you need to use the OCR equal to TCNT plus count minus 1. So this is the formula that you need to use. Okay, replace with the TCNT sama dengan FF minus count plus 1. Okay, now we will replace with this what we call here equation. OCR equal to TCNT plus count minus 1. And the TCNT is always 0. Why? Because from this first step, okay, you always clear your TCNT. So actually, the OCR equal to count minus with 1. Okay, so you load your OCR based on this equation number 3. Step number 3, what you're going to do here is, okay, you need to set the TCCR. Okay, sama dengan previously. Step number 4, okay, monitor the flags. Okay, so in this case, we are going to monitor the OCF flags. Okay, if OCF flags equal to 1, what happened here is number 5, stop timer. How to stop timer? Put TCCR 0 sama dengan 0. So this is how you're going to stop the timer. And step number 6, okay, what happened here is, okay, after you stop timer, then you need to reset. Okay, clear your clear OCF flag. How to clear an OCF flag? By put 1 to your TIFR register. Okay, so you need to put kat sini. Okay, so this is your this is your TIFR register. Okay, you need to put 1 to your OCF0 punya location. Okay, to clear the OCF0 flags. And step number 7, okay, the last step here is, okay, you're going to repeat step 1. Okay, so this is the CTC mode. Okay, next class, okay, we're going to look at this, what we call here, examples here. Okay, any question up until here? Ada soalan tak?